Hi, now we will start Technical Session 3. The session chair is Pumudu Fernando, Senior Lecturer, IIT.
Hello everyone, welcome to the session 3 of the computing track. So we have two papers to be presented in this session. So the first paper title is Heller, a Sinhala language based programming language, presented by Rajitha Hathurusinghe, and also there is a contributing author, Professor Damitha Karunaratne, and the affiliation is University of Colombo School of Computing. Rajitha holds a computer science degree from University of Colombo School of Computing with a second class upper division, and also he has a software engineering degree from Java Institute of Advanced Technology affiliated with Birmingham University with a first class. He's passionate about the financial technology and currently working as a software engineer in LSCG technology. His main research interests are computer graphics, computer security and cryptography, and theory of computation. So we would like to invite Rajitha Hathurusinghe to present his paper.
Good afternoon, I'm Raja Yasasri. With this research work, I'm presenting a novel programming language inspired by Sinhala language. This is a presentation plan starting from introduction to limitations. Basically, this is a research on how Sinhala language can be used for programming as a programming language. There are many reasons we can need for this kind of research in terms of localization, cultural diversity, and accessibility. You know that there are many people who lacking English proficiency, so it is difficult for them to access technical education for specifically technical documentation kind of thing, and there may be scenarios for like these kind of languages may be more suitable for NLP task as well, and for innovation. Moving on to the related works, you know that every programming language needs a grammar. In this programming language, the grammar is based on this grammar. This is a feature-based computational grammar. There are many features for different lexical categories of the Sinhala language words. And then we have Silonicus programming language. This language can run both Sinhala and English syntaxes. This is a Python interpreter, but the syntax can be more improved towards the natural Sinhala kind of a syntax. So with this research, one of our motivations was to go steps forward and introduce more similar design to Sinhala language. Those are some of the foreign works. For example, Phoenix programming language targets Arabic natural language, Doolittle language primarily for Japanese, so and so forth. Research objectives and methodology. First, to propose a programming language that is more closer to Sinhala natural language, and also for develop a parser for this proposed programming language. Methodology, there are main two phases. In these phases, in the first phase, we finalize our design, and the second phase, we develop the parser. You can see that both phases we did it iteratively. We refined the designs and then came up with a new design and then tested them. Moving on to the programming language design, these are some of the features of this language. This is keyword based. Use only Sinhala Unicode characters. Nested is supporting the delimiter. Block delimiter is the dot character. These are the keywords currently supported in this programming language. And the same typical logical and comparison operators are also supported. These are examples for main constructs of programming language. For example, print statement can be used like string followed by the word lianna. Variable assignments we can use like pot degai 2 is the value, pot is the variable name, and e indicates that this is an integer. Likewise, arithmetic operators, we can use the typical numerical operators and or substitute them by words, or like more naturally how we express a mathematical operation. And these are the conditions and loops. Comments, we use brackets. These are some of the sample codes written from these statements, and in the below there's a red sentence. This language we designed this to also give the errors in Sinhalese. This is an example for arithmetic exception divided by 0 error. Implementation, we used Antler to generate Lexa and parser. Antler 4 is actually a powerful open source parser generator. This is a simplified version of the compiler. There are quite a few components. This is a file structure of the Java compiler. This is starting from the command line client, and then the preprocessor. Removes the comments and converts the source text into a char stream, and then Lexa and parser, which are generated by the Antler generator, and then visitor component is the place where the parse stream manipulations happens. And then there are two error listeners, compile time error listeners and listener and the runtime error listener. These error listeners catch the exceptions and map them into pre-built Sinhala language error messages. This is a part of the final programming language grammar evaluation. We first conducted a user study from 61 different experienced developers. We got many insights and their feedback. We asked whether a single language based programming language is needed, and many voted yes. And in what language would you like to have the error messages? And to our surprise, most of them voted for both English language and the native language. At the same time, when we asked why, they told that if correct issue cannot be located, cannot be identified with the error messages thrown in many languages, so they prefer to have the error message in both the English language and their native language, Sinhala language as well. And then we conducted two user studies involving two students who had too little knowledge of programming, and those participants were taught main constructs and then asked to write a sample program. And we found out that it is easier to understand if-else kind of constructs, but they are having a difficult time to grasp for loops. Then limitations and future works. Error mapping is not completed because the exception hierarchy is very complex and huge, and there are no direct Sinhala words for many examples. For example, for the null pointer exception, there is no direct Sinhala word. And then remaining constructs, functions, data structures, Boolean types are not yet implemented. And finally, the Unicode character usage poses many challenges. You know that typing Sinhala characters is not that much intuitive. There are many future works. We can use different design approaches and object-oriented approach. How we can use classes for this kind of language, and the error mapping. And you know that Sinhala is a morphologically richer language, and these properties can be used for improve the design. And this concludes the presentation. Thank you.
Thank you, Rajita. So we can move into the Q&A session. If you have any questions, please feel free to ask.
No, no. Inspired by Sinhala language.
Yeah, true. I can understand. I'm asking like the syntax, the format of syntax is inspired by
No, 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 no.
your one.
It is it is a language independent. We can build compilers for Java, JavaScript, or Python, or C++.
No, I'm asking the syntax order. Like we have shown an example, Mihi, case hitter. Can you go to that?
Yeah, sure.
I think it's asking whether you used any parent language when you are developing the main syntax and the order logic.
Some of them, actually, these are the main construct you can find in any language. Actually, this is not the. This is අංකයට වඩා විශාලයි close is the condition. But if we take a programming language like Java, we say if and then condition. But in here, first the condition and then num.
Okay, so you use Java for the implementation.
Yeah, currently Java compiler, but we can develop other languages.
Okay, so basically how the methodology works, like when you input such a sentence,
Yeah.
how internal process happens? Can you repeat another?
This oh yeah. First,
Preprocessor test?
sorry.
Like can you little bit like explain how what is this preprocessor test? What is Lexer test?
Preprocessor currently removes the comments and then it converts the source text into a char stream and then Lexer takes that char stream and converts into a token stream. And then the parser takes that token stream, create the pass tree. Then the visitor visits the pass tree and give the output.
Your syntaxes seems that when it comes to English language, syntaxes becomes longer usually
Yeah.
compared to the English one. So have you looked into how much time it takes to compile a program, the complexity of the code, and that time also the readability and from the user's point of view, that part. Have you done any testing of that?
We found out that point in our user study. Because that is more lead.
That, like how much because like the convention is to like use less number of
Yeah.
lines to
Yeah.
write a code optimum coding. So have you done any testing on whether this kind of syntax it does not really use that convention?
No, because the goal is to create a more natural design, because then the students can more easily relate into. So they can easily learn the basic concepts, and then they can move into some other language like Java, C++.
And also the advantage when using syntaxes, it will be easily readable and easily recall value is important.
Yeah, yeah.
Recall syntax is
Yeah.
syntax is very simple, right? Because it has the recalling capability should be there.
Yeah.
So have you tested on recall? What is the have you done any user testing on recalling of these syntaxes and all that?
We asked that that point yeah, in of our user study, and one participant told that yeah, rememberability is bit low because that should be because this is lengthier, and then they should.
Some of the like using like combination words.
Yeah.
So you could have removed those in this from the syntaxes. Even if you remove those from syntaxes, I don't think it won't be a problem. So
So the motivation for this is you mentioned that Silonicus is already there, and then it's what you are expecting is to get this to be more closer to natural, and in your I guess you haven't come across any research or any data about now you have found users. The user study is to just look at. I assume they are well versed in Silonicus plus yours too, because your comparison is between the two, isn't it?
Yeah.
Whereas you haven't. Other than that aspect, other than the closeness, now as it is right now, any other comparisons in terms of Silonicus, like in terms of functionality? Have you gone beyond anything like, or is there any coverage-wise? Is there any difference?
No.
So it's only the
Functionality wise same, and this is there's one difference. This language can give the errors in Sinhalese as well, but
so in Silonicus it is not the case.
yeah.
All right.
Thank you for the that informative presentation. So this is like more general question now. In your review, did you come across any approach to compare different natural languages in their appropriateness for being used as programming languages? For instance, I have heard somewhere that Sanskrit is a very good language for computers because it's very structured and so on. But is there kind of a methodology to compare languages in their how good they are, maybe based on the output that they produce, the efficiency of the code or the binary? Is there any comparison that did you come across any such?
No.
Or is there any method that you?
No,
come across any method?
actually, in the literature they use mainly user studies. But I found I think there are some other methods as well to get some a numerical value, qualitative value.
Okay, thank you.
Just one question now. Your intention is to just build kind of a teaching programming language or go beyond and improve it to a kind of a strong type language like Java or C#, or just through this to teach the basics of programming?
Just to teach, not to replace Java, Python-like language.
Any other questions? Right, thank you, Rajendra.
Thank you.
So the second paper is Alternative Transport Layer Protocol, presented by Harshi Prabha Sepala Ratnayaka, co-authored by Geeta Priyaliyanage from Informatics Institute of Technology, affiliated to University of Westminster. So the presenting author, Harshi, is graduated from University of Moratuwa, Electronic and Telecommunication Engineering. She has worked in Etisalat Private Limited as an engineer, specialist and senior engineer in transport network planning. She has also worked in Central Engineering Consultancy Review as a head of IT. And she has recently taken her master's degree in cybersecurity and forensics at IIT. Her research interests include cybersecurity, computer networks, network security, and transport layer protocol. So we would like to invite Harshi Ratnayaka to present.
Hope I'm Good afternoon, ladies and gentlemen. I'm Harshi Ratnayaka from Informatics Institute of Technology, affiliated to University of Westminster, and the co-author of this research paper is Mr. Geeta Priya Lienage from Department of Computer Science and Engineering, University of Moratuwa, and he is the supervisor of this research paper. This is the agenda for today's presentation. Let me first introduce you to the problem background. What is a network? A network is a collection of devices where you can use to transfer data from one point to another between 2 points. So the biggest network so far known to us is the Internet. Transmission control protocol is the protocol that dominates the Internet today. So, surprisingly, this TCP protocol is 4 decades old. So, most of the solutions in the literature only proposes modifications to transmission control protocol rather than replacing TCP. TCP was proposed in RFC 793 and recently obsoleted by RFC 9293, but that RFC also haven't proposed any major modifications to the old protocol. This is the TCP/IP protocol stack, and transport layer is the third layer, and Internet layer is dominated by Internet protocol, and it is also similar to TCP, 4 decades old. The research gap is the TCP has been a very old protocol. Most of the researchers were done to modify it or identify and provide solutions to security problems of TCP. None of the researchers have proposed to replace TCP. This is the main problem of TCP. In TCP, there are 3 stages of communication that take place before TCP session is created. That is, we call handshakes. So these 3 handshakes take place in plain text. So when this plain text communication takes place, someone in the middle can interfere into the communication and read the packets that are being transmitted. So the security solutions provided by researchers are like protocols like TLS or SSL, and they try to provide a solution on top of TCP rather than replacing TCP. So the research identified during this research was TCP haven't been replaced, and it has been in the Internet world for 4 decades, and most of the researchers were trying to provide modifications or provide security solutions on TCP, on top of TCP, and only one framework was found during the research literature review, and it also haven't addressed the security concerns of TCP. So, rather than finding problems of TCP and security issues of TCP and proposing some modifications to TCP, this research intended to provide a replacement solution for TCP. So the research problem is TCP's three-way handshake takes place in plain text that gives a man in the middle to intercept the communication and access data in transit. There is no comprehensive solution for this problem yet. As the solution in this research, we first consulted experts in the network industry and found the expected or the essential aspects for a secure transport layer protocol. Then we tested the TCP and TLS protocols inside a virtual environment and found the problems in TCP and TLS or the SSL protocols. Then, using the gathered data, we formed a framework to develop a transport network layer protocol. Using that framework, we designed the alternative transport layer protocol to replace TCP. Now I will discuss the framework we have developed. This framework consists of 6 requirements for transport layer. Those are ensuring the end-to-end communication channel, authenticating the 2 parties involved in the communication, confidentiality of data, integrity of data, removing retransmission problem, large-scale deployment. This framework was derived using the results from the data collection phase of the research. And during our literature review, we found that API ossification was considered as one of the main limitations for TCP evolution. But when we consulted the experts in the network area, we found that API ossification can be overcome by using kernel-level programming. So this was not considered as one of the requirements or the limitations in the transport layer. Then backward compatibility and middle box compatibility was not integrated into this model, because when we introduce backward compatibility or the middle box compatibility, it introduces vulnerabilities into the protocol. So we didn't consider this aspect. Let me present you the alternative transport layer protocol, in short ATLP. We call it alternative because we intend to replace TCP with this protocol. During our research, we identified 6 functional specifications for ATLP. These are listed here, and I will discuss those specifications one by one. This is the protocol packet format for ATLP. It has source IP, destination IP, coming from the IP header. In addition to those, we have the source port, destination port similar to TCP, and we have the signature, public key, certificate, flags, then packet length, question field, answer field, and random text or data field. These question, answer, and random or the data fields are encrypted. This is showing the ATLP handshakes. It requires only 2 handshakes to form a secure communication channel. The first packet is sent from A to B. You can imagine A as the client and B as the server. So from A to B, we are sending a packet containing source IP, destination IP, source port, destination port, signature, public key certificate of A, then the flag stating hello 1, then the packet length. When B receives B can find the details about A through A's certificate and verify its certificate and the signature. Then B, as the response, sends back another packet with the flag hello 2. It contains similar information like the previous packet. And in addition to those, there's a question field. In the question field, B is asking A to send back some particular octet from the random text field. The random text field can be the payload or just a random text field generated by the B side. So when A receives that, A has to send the response in the next packet, and the communication can continue using this question and answer method continuously. In the first 2 packets only, they are exchanging the certificate and the signatures. This is the state transition diagram for ATLP. It has 12 states. State transitions depends on the current state and the message flags. There are 6 message flags: hello 1, hello 2, data, close 1, close 2, and wait. The main difference between ATLP and TCP is ATLP is replacing sequence numbers used in TCP. Most of the attacks takes place because of the sequence numbers used in TCP, because threat actors can predict or guess TCP's sequence number. So rather than using sequence numbers, we are using question and answer method, so we can eliminate that threat. In ATLP, we are using digital signatures. So A and B, both parties have their self-generated certificates and public-private key pairs, and the certificates are signed using the private key of each party. So we use these digital signatures to authenticate each other during the communication. There are 6 features of the protocol. The first one is the signatures to ensure the authentication of A and B. Then the second one is self-generated certificate. It reduces the hassle of contacting the certification authority every time the certificate expires, and there are certain vulnerabilities involved with certification authority. So it was written in the literature also. So with use of self-generated certificates, we can eliminate that threat. Self-generated public and private key pairs also achieve the same target. Then we have the client and server to drop packets that arrive without a signature. That provides protection from spoofing attacks. Then we have question and answer method. It is used as the acknowledgements from the receiving party and the readiness to receive the next packet. Then there are flags. As I have discussed earlier, there are 6 flags involved in this protocol. Testing and evaluation. To evaluate this ATLP, we compared it with the framework developed and also with the transmission control protocol. So when we compared it with the framework, it proved that ATLP has addressed all the areas of the framework, and in addition to that, it has addressed all the most of the problems in TCP, especially the retransmission problem of TCP, then the sequence number problem of TCP, then the confidentiality and integrity authentication problems of TCP. Then we consulted the experts and presented our new protocol for the evaluation, and most of the experts agreed that this is a promising protocol, and they indicated that this question and answer method is an innovative and practical concept that can be implemented in practical networkers. So when I turn to the contribution to the body of knowledge, this research provided a framework to develop a secure transport layer protocol and also a comprehensive protocol designed to replace TCP in future. Future enhancements wise, this protocol can be presented as a request for comment document to Internet Engineering Task Force, IETF. Then this protocol can be further developed as operational transport layer protocol. For that, we need to do kernel level programming for client and server sides and test the communication using the new protocol. In conclusion, to overcome security issues and other issues of TCP, many solutions were proposed in the literature, but most of the solutions were on top of TCP or trying to modify TCP. None of the solutions offer the opportunity to replace TCP. This research main technical contribution was to finding a comprehensive solution to replace TCP. Proposed framework and the protocol could be used to develop a fully operational secure transport layer protocol in future. Expert feedback and the results from the evaluations, which compare ATLP against the framework, TCP and existing protocols, confirm this outcome. Thank you, and it is the time for the questions and answers.
Floor is open for questions.
So in terms of overhead of implementation, how would it compare against TCP?
Overhead of implementation.
Yeah, so let's say you, if you use this in a practical scenario, what are the overheads when compared with TCP?
Yeah, actually in TCP also we have to use TLS or SSL, which use encryption. So there is also an encryption part that the machine has to undertake. So in here also we have the encryption for the question field and answer field as well as the payload. So there's a very marginal increase of encryption and decryption overhead increase when we compare the TCP and ATLP in computation wise.
There are no metrics to I mean, you can't come up with any metrics for that, right? At this stage, like, okay. Anyway, right.
Yeah, thank you for that interesting presentation. So you are proposing not just a replacement for TCP, but on top of TCP, if you have SSL, you are proposing to replace that as. Now, this retransmission and sequence numbering, as far as I know, it's there to avoid this two-army problem. So you can't be sure whether the other party received the message, right?
Yes.
In an unsecure channel. Now, in this case, are you claiming that it addresses the two-army problem?
Yeah. By this question and answer method, think A and B is there. B is asking for a particular octet from the sent data for A to send back as the answer. So that data is also encrypted. So we are asking for a particular octet from that encrypted data. So when A receives that, A has to decrypt the data and find the particular octet and send back that octet to B in the next packet. So B has the confidence that A has received the exact packet and no one has interfered into the traffic, because the encryption secures the data.
Right, but still if the original question doesn't reach the recipient for some reason, network issue or something, then again you have to retransmit.
Right? Retransmit, yes.
so that retransmission can still occur, isn't it?
Retransmission.
Because it's a more
Yeah.
fundamental
Yeah.
issue.
Retransmission, actually, we have limited it to for the to make the presentation short. I didn't present those details. I have limited it to 3 attempts. When there's no response from the other party, the connection will be closed by the party who is waiting for the communication.
Okay.
But in TCP, it continue to send the packets when it doesn't receive the response packet, the acknowledgement packet.
Yeah, I think, yeah, like the professor said, the evaluation could have more quantitative comparison, like maybe because overhead is also a key issue, right? You need to reduce the number of messages, and whatever the matrix that is currently used to evaluate different protocols, it's better if you could have included that in addition to the expert evaluation.
Okay, sir.
Thank you.
Thank you. Thank you.
Thank you everyone for the presentations. Now I would like to invite Ms. Naomi Krishnaraja, Dean School of Computing IIT, to present the token of appreciation to Mr. Pubudu Fernando, Senior Lecturer, IIT. We have concluded the technical sessions. You may now proceed to the main hall. Thank you.